Assalamualaikum warahmatullahi wabarakatuh. We are from group number 3 and today we will present about our POPBL project, which is IoT-based water purity assessment analyzing oyster filtration efficiency in Muar River. So this is our project poster and we will explain part by part. First is abstract. The Muar River in Johor, Malaysia plays a vital role in supporting local ecosystem and livelihood, with oyster contributing significantly through their natural water filtration abilities. However, increasing pollution from agriculture, domestic and industrial source threaten both water quality and the health of oyster population. To address this issue, an IoT system is proposed to monitor real-time water quality parameter and evaluate the filtration efficiency of oyster in the river.
Next is problem statement. The Muar River, an important water source and ecological asset in Johor, Malaysia, has seen increasing pollution levels due to agriculture runoff, domestic waste and industrial activities. Oyster, known for their natural water filtration capabilities, are present in part of the river and offer a potential bioindicator of water quality. However, there is limited scientific data on the filtration efficiency for this oyster in the context of more rivers' unique environmental conditions.
For the market potential, this project has strong market potential, especially in areas of environmental monitoring, aquaculture, and smart water management. In Malaysia, rivers like Muar are important for oyster farming, tourism, and local ecosystem, but are at risk due to pollution and industrial waste.
Hello, my name is Adam Faris. So this map shows the deployment of water quality sensor along the Muar River in Parit Tiram. The top icon represents the turbidity sensor, which measures how clear or murky the water is useful for detecting runoff or waste. The left icon shows the pH sensor, which checks the acidity or alkalinity of the water, important for aquatic life and pollution detection. The bottom right icon is the TDS, total dissolved solid sensor, which measures the concentration of dissolved substance in the water, key for checking water purity. These sensors work together to provide real-time environmental monitoring using IoT. For this one is a benefit, which this slide explains the benefit of the IoT-based river monitoring system. It supports conservation efforts by detecting turbidity caused by water or runoff. Oyster farmers benefit from pH and TDS data to maintain a clean, suitable environment for sailfish. Using apps like Blink, data is sent remotely for easy access. The system also helps authorities enforce environmental regulation and monitor pollution trends earlier, allowing quick response and better water management.
This is our block diagram of this project. We make a coding by using Arduino IDE software and we use microcontroller ESP32 that are connected with 3 sensors, which is turbidity, pH and TDS sensor, and then the microcontroller will send the data gathered from the sensor and the end user will see the data from the Blink, which is mobile app.
Assalamualaikum, my name is Mamadini. Next, I want to explain about the codes. First one is define Blink template ID, which is the required for connecting device to the correct Blink template. Next is for the CHA house and the MX start queue, the codes is for the authentication code token from the Blink project. And then below the float simulate turbidity is the turbidity simulation, which is for the 0.0, that is to declare a static variable, which means to keep its value between function call. turbidity 5.0, which is increase the turbidity by 5 NTU each time the function runs every 10 seconds. The turbidity is greater than 100. That means the system resets the value to 0 once it passes to 100 to simulate a loop of reading. Next, which is for the TDS sensor. That is for the static float TDS, which equals to 50 is for the starts at 50 ppm parts per million. Next is the TDS plus equals to 25 is for the increase by 35 ppm each time it's called. And next is to reset the 50 ppm after tracking 500 ppm. And next is for the pH sensor. For the pH 6.5 is which means it is slightly acidic. And then 8.5, once it reaches 8.5, it is slightly basic and it will reset back to 6.5. So which means that this project is like a mimic for a normal environmental water condition. For example, like agriculture or fish tanks. Next is for the sending all census data to the Blink. Void sensor data is the function is to send the simulated sensor values to the Blink app. And then for the void setup, which is for the initialization serial communication that will connect to Blink over Wi-Fi. And then for the void loop, blink.run is for the keep the Blink collection alive. And timer.run is to ensure your sensor data is sent regularly, which is the real time. Okay, that's it for the codes. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muar and my matrix number is CN220338. So next is our simulation. As you can see, these are two output from Arduino IDE and Blink app. From the data we gain is three things: turbidity, TDS, and pH. All those three output will come out on the Blink app. So that's all from us. Thank you very much.